Static versus dynamic characteristics of instruments. Introduction. When we talk about instruments, whether it's a pressure gauge, a thermometer, or a flow meter, one thing is clear. The true value of an instrument lies not only in what it measures, but also in how it responds. To understand this, we divide the behavior of instruments into two categories: static characteristics and dynamic characteristics. Static characteristics. Static characteristics describe how an instrument performs when the measured quantity does not change with time. These include accuracy, how close the measured value is to the true value; precision, how consistent repeated measurements are; sensitivity, how much the output changes when the input changes slightly; linearity, how well the output follows a straight line relation with input; hysteresis and repeatability, how reliable the instrument is when used again and again. Think of a weighing scale in your kitchen. If you place the same apple 3 times and it shows the same reading every time, that's precision. If the reading is very close to the actual weight, that's accuracy. Dynamic characteristics. Dynamic characteristics, on the other hand, describe how an instrument behaves when the input changes with time. Key terms include speed of response, how quickly the instrument reacts to a change; fidelity, how accurately the output follows rapid changes in the input; lag, the delay between input and output; dynamic error, the difference between the true input and the output when conditions change. Imagine a thermometer dipped into hot water. It doesn't instantly show the new temperature. Instead, it takes a few seconds to adjust. That delay is part of its dynamic behavior. Why this matters? Understanding static and dynamic characteristics is crucial for engineers and technicians. If you need precise long-term readings, you focus on static characteristics. If you need instruments that can follow fast-changing signals, like in automation or medical equipment, you focus on dynamic characteristics. Conclusion: instruments are like human beings. Some are steady and reliable when things stay the same, while others are quick to adapt when situations change. Mastering both static and dynamic characteristics allows us to select the right instrument for the right job.